Here is the dsPIC starter kit board. In the centre of it here is the dsPIC processor itself. Now that's a system-on-chip device in the sense that it's surrounded with built-in peripherals, but those peripherals connect to other things. And everything else on this board is designed to support that particular processor. First of all, over here we have the power supply, and here we have a USB interface. The USB interface is going to let us connect a computer to this board, and then download programs to it and debug them in real time on the device. Here is a second microcontroller. That's a simple PIC microcontroller, and its only purpose here is to support the USB interfacing for downloading of programs and the debugging. So this section here is really the power supply and debugging section. Here we have 4 megabytes of flash memory. That provides the memory to store the programs, any permanent data, and it's also used to store temporary data that's used within the programs. Down here we've got 2 switches. Each of those is attached to an input port on the device, which is a digital input, and it's very easy for us to read those digital inputs to see the state of those switches. On the right hand side of the board at the bottom we've got a red, amber and green LED, and each of those are attached to an output port. That's a digital port that we can switch on to switch the LEDs on, or off to switch the LEDs off. Here is a microphone input and a preamplifier with a gain control. That allows us to input audio to the dsPIC processor, and that's using a built-in analog to digital converter. So this is what's called a mixed signal device because it has analog and digital capability. For output, the PIC uses pulse width modulation. That's a type of digital output that you may know about, and it's output through some very simple cheap analog filters to return it to being an analog signal. These are the analog filters up here. As an alternative to that, we can connect the device to an audio codec, which is an analog to digital converter and a digital to analog converter, which gives us a higher quality of audio, but at the expense of adding an additional chip. And in many applications we're very concerned not to add cost in that way. And that is followed by an amplifier here, and then the speaker output over here. So in all, you see that we've got a very simple system centered on the dsPIC device, with everything else being attached to the peripherals on that device.